Hello and welcome to this last session of this year's 24 Hours of Past. We are really glad that you can join us today for Ryan Adams' session on SQL Server AlwaysOn Quickstart. As you know, this is a 24 consecutive live event that have been taken over for this last 24 hours, and it's just about to finish now. The sessions will be recorded and posted online soon after the event. And my name is Ásgeir Gunnarsson, and I'm a business intelligence consultant located in Iceland, and I will be moderating this session. Before I hand it over to Ryan, I have a few quick introduction slides. So Ryan, if you can move on to the next one. If you have any issues, you can type your issues into the question pane, and someone will assist you or try to help you to solve that. To maximize your screen, use the Zoom button. It's located on the top left of the screen. And then in the end, we will have our Q&A session. So you can type your questions in the question pane as well, and we will come to them in the end. I will read them out to Ryan. When this session finishes, there's going to be a short evaluation, so your feedback is important, and I hope you take the time to complete it. We would like to thank our partners. These sessions would not be free without their support, and we are really glad that both Microsoft and Dell Software have supported this. Next, please. As you know, most of you know, this 24 Hours of Past is a preview of the Past Summit 2014. This is the largest conference for SQL Server professionals and BI professionals. It's going to be around 5,000 attendees from 2,000 companies from 52 countries. So it's going to be a perfect place for you to share, connect, and learn from your peers and with your peers. It's taking place in Seattle, Washington, from November 4th to 7th. And it's gonna be 190 world-class sessions all across 5 topic tracks. Now, these 24 hours of past are a glimpse into what the real conference is about. So I hope you will register and go to the conference. If you do, you can sign up using the discount code 24HOP14 until September 26th, and you will get $200 off the registration fee. Next, please. And now I'm going to hand the stage over to Ryan to introduce himself and take you through the session.
Thank you, sir. Appreciate it. Oh, there, looks like I got into mute there for a second. So good morning, everyone. At least it's morning for me. So I live in the Dallas, Texas area. So it's about 6 o'clock in the morning here for me. I am a senior systems consultant and DBA for Verizon. I've worked for Verizon for about 16 years. I've done a lot of different things in my career at the company. The group that I work with now does identity management, and I handle all of the databases on the back end of that. We also do a lot of our mobile stuff and Exchange and things like that. So we've got stuff that's homegrown and in-house, and we've got a lot of stuff that is vendor applications. I'm also extremely involved in the PASS community. I serve on the board of directors for the North Texas SQL Server user group here in the Dallas area. I've been involved with that group. I've been working with them for about 10 years now. I am also the president of the PASS Performance Virtual Chapter, so if you're enjoying these sessions that you've had in the last 24 hours of 24HOP, make sure that you go check out all the virtual chapters. There's some just amazing content out there, so make sure that you go out there and check them. We've got virtual chapters for just about everything. I'm also a regional mentor for PASS, so with that, my role is to kind of help all of the chapter leaders in the South Central area of the United States. Just make sure that they have the tools that they need to be successful with their groups. All right, so today we're going to talk about AlwaysOn Quickstart. You'll notice that I do blog on ryanjadams.com up there in the top left-hand corner. So you can also go out there and subscribe to my RSS feed, check out my blog. If you're on Twitter, my handle is Ryan J. Adams on Twitter. So I encourage you to go out there and follow me on Twitter if you're on Twitter. I do talk about this stuff quite often on Twitter. Any of my blog posts that I put out, I always announce this on my Twitter account, so make sure that you check that out. I'm also on LinkedIn, as you can see. Obviously, I'll be speaking at the PATH Summit this year. I'm a friend of Redgate, and I've spoken at several other conferences. So let's talk about our objectives for today. So the first one is I want to talk about and kind of discover the always-on feature set and exactly what that encompasses. Today's session is really an intro session to kind of get everybody familiarized with exactly what always-on is and the different features that are included. Then we'll talk about failover cluster instances next. From there we'll move on. We'll talk a little bit about availability groups. We'll probably spend more time on availability groups than anything. We'll talk a little bit about how Windows Server failover clustering comes into play. Not necessarily the SQL side, but we want to make sure that we understand the Windows side of that and the difference that that plays. We'll talk about multi-database failover and the advantages that gives us that we didn't have before, what an availability replica is, and last we're going to talk about active secondaries and the new cool things that we can do with those. So what is always on? And first and foremost, it's a marketing term that Microsoft put forth. And if you were to come up to me and say, Ryan, I need some help with an always-on solution that I'm working on. Can you answer some questions or help me out with it? My first response to you is going to be, well, do you need help with a failover, an always-on failover cluster instance, or an always-on availability group? Because that term always-on is a generic, all-encompassing term that means failover cluster instances and availability groups. But in order for us to talk intelligently about it, I've got to know which one are we talking about, an FCI or an AG. So it kind of encompasses both of those things. So I always encourage you when you're talking about it, make sure that you specify which one we're talking about. Now for each one of those, this is what we will get out of it. So for an FCI, a failover cluster instance, we get those top two things you see there. And the first one is server level protection. And what that really means is I am protected against anything on a hardware level. It also means I'm protected against anything on an operating system level. So it doesn't necessarily have to be a physical piece of hardware. It could be a virtual machine. But this gives me protection against both of those scenarios if either one of them were to fail. Either the physical piece of hardware, somebody kicks a cable out, walking to the data center, backplane goes out on your server, maybe it's a VM, your physical host goes down, the operating system blue screens on you. You get protection at that high of a level with an FCI. It also gives you SQL Server level protection. So it's going to protect you against the actual engine itself and the binaries of SQL Server. Now an availability group, on the other hand, is at a much smaller scope below that. It doesn't protect us at that high of a level. It is only at the database level. So on a per database level is where we gain that protection. What we also get out of an availability group, and we get this in FCI as well, but it's kind of, for those of you that are familiar with FCIs, it's kind of inherent in its nature. It's already there because we already think of it as a package all in one, which is something I'm going to try and break your framework and your frame of mind on that a little bit today. But it gives us this abstraction level for our client connection point. And all that really means is that an availability group can work just like an FCI, where I have a single network name that I use to connect to it with. That way I don't really need to know which node it's sitting on underneath or which server underneath it's sitting on. So let's talk about failover cluster instances first. So don't worry about availability groups. Don't even think about that right now. Let's only think about failover cluster instances. So what can you cluster? Well, the good news is you can cluster the database engine, and you can cluster analysis services. What you can't cluster, though, is reporting services, integration services, and the browser. Now, I've got an asterisk by the browser there, and the reason I put that asterisk there is because you can't cluster it because the browser service already exists on every single node. Nothing you can do about, so you don't really need that one to be clustered because it's going to be running on every single node. Integration services is something we cannot cluster. Now reporting services, although I put that in the no column, all that really means is that you can't cluster the reporting services service itself. You can, however, put the databases themselves, so report server TempDB, those two databases, you can host those in a failover cluster instance, just not the service itself is not natively supported. Same with analysis services, although it's well, analysis services is natively supported. So what is an always-on failover cluster instance? So I've got this diagram here to kind of explain a little bit, if you're not familiar with an FCI, kind of what it looks like. Now we can have more than the 3 nodes that we see here, but these are 3 completely different servers. They could be physical servers, they could be virtual servers, it doesn't matter, but they are different server operating systems. But what you're going to notice there is the common denominator is that SAN. Now that SAN, if you think about the way that that's designed, can be a single point of failure. So the good news is the reason that we have protection against the server level, the operating system, and the SQL Server binaries is because there's a separate install of the operating system and SQL Server on nodes 1, 2, and 3. So if node 1 fails and it flips over to node 3, we have a fresh operating system sitting there, a whole other install of SQL Server, everything's ready to go. But we don't get a whole lot of protection on that database because the database files, the physical databases and log files are sitting on that SAN. Well, that SAN could be a single point of failure. You may have redundancy built into your SAN, but generally speaking, if you were to lose that physical piece of hardware, unless you were replicating it to another one somewhere, that's a single point of failure. So be very aware of that when we talk about FCIs and being high availability. Although it is a high availability solution, not everything is really covered as far as high availability goes because you still need a backup plan for what happens to your data files. Now, if you're already familiar with FCIs, you're probably asking what's new. Seems kind of like old hat. Okay, we know what FCIs are. Some of you are familiar with that. But what's the new stuff that they added? So the very first thing that they added was multi-site clustering. Now you're going to hear this used by 2 other terms other than multi-site clustering. One of them is going to be called geo-clustering, which means that you have a cluster that is geographically dispersed or nodes that sit in different physical locations. And the last one is multi-subnet. No matter which one, whether you hear multi-site or geo-clustering, in your mind I always want you to think of multi-subnet. That's what it really means, because that is the differentiator here, not the fact that it is in different geographically dispersed locations. The fact that you have a server sitting on the East Coast and another one sitting in South Africa does not mean that that is the differentiator. What it does mean is that the multi-subnet, because those are going to be in different subnets because they're so far away, is a differentiator. What that also means is that you could have 2 nodes sitting in the exact same data center in racks right next to each other, but be in different subnets. And that is where you will need this multi-subnet / multi-site / geo-clustering technology in order to make that work. And all that's really doing, and it's really, really simple in its most basic form, is it allows you to have multiple IP addresses for your network name. And before we only had an AND clause, now we have an OR clause. And what's really cool about that is it means that, hey, if it comes up in South Africa, I can use this IP, or this one, or this one. But if it comes up in New York, then I could use this one, or this one, or this one. So no matter where or whichever node becomes live, it will be able to use an IP address that is valid on its network. And that is huge, really, really huge. So no more VLANs in order to solve this problem, none of that. We've got that built in. Last thing to note there is your network name. That host record or your A record is going to need multiple IP, will have multiple IP addresses for that DNS name. So obviously as your clients go in and they hit server 1, well, you've got maybe 3 IP addresses because they're in 3 different subnets. You'll have to tie 3 IPs to a single DNS name. The next nice thing that they added was TempDB no longer has to be on shared storage. So think about the diagram that I showed you a minute ago with a failover cluster instance having to sit on that shared storage, all your database files. Now that's true for your user databases. That's true for master, model, and MSDB. But Microsoft realized, hey, what about TempDB? Do we really need to have that on shared storage? Because what happens with TempDB when SQL Server restarts? SQL Server recreates TempDB. So it's toasting it and recreating it on restart. So why does that have to be on shared storage? Because I don't need the data at rest to be in the exact same form whenever I move over from one node to another, because I'm actually recreating the entire database. So now, instead of doing that, I can put that on local storage. So that can be stored inside my physical servers, which means I can put it on a RAID 10. Maybe I could put it on some really, really fast RPM drives. Maybe I could put it on solid-state storage. So that if you're experiencing a lot of TempDB contention, this could be a huge game changer for you when it comes to failover cluster instances, because now we can put it on much faster storage and get that much more I/O out of it that we couldn't get before. Now, that does not mean that you can't do your regular troubleshooting for figuring out why you're getting a lot of TempDB contention. You still need to go figure that out, multiple data files, so that we're not having contention on PFS, SCAM, and SCAM pages. Robert Davis, SQL Soldier, at SQLSoldier.com, has got an excellent white paper on troubleshooting TempDB. So if you're having troubles with TempDB, I encourage you to go look at that first. But this can be really, really huge to increase that I/O in addition to and on top of troubleshooting and making sure that your TempDB is configured correctly. Now, when you go to install this and you're building your cluster, there's a little bit of a caveat I want you to be aware of that's something I'm not a huge fan of. When you go and you create the very first node and you go to install that guy, it will actually pop up, and as soon as you put it on local storage and you give it a local drive, the SQL Server install will pop up a warning and say, hey, I noticed you tried to put TempDB on a local piece of storage and that's not shared. I don't see that available on all of your other nodes. I want you to be aware of that, and I want you to be aware of that for a couple of different reasons. One of which is there is a directory that you have given me. So if I decided to put it in C:/databases, by the way, don't ever put it on C. If that's where your operating system is, don't do that. Just because you can put on local storage doesn't mean you put it on the C drive. But let's say you're putting on C:/databases is where we're going to put it at. So we type that in, and it goes, okay, that's great, but you need to make sure that the SQL Server service account, whatever's running the SQL Server service, please make sure that it has permissions to that folder, and make sure the folder exists on every node in your cluster. Now that's great on the first one, and the honest truth is on the very first node, you don't have to create that folder. If it doesn't exist, it will create it for you, and it will also give the account permissions. But what it's trying to really warn you about is make sure that on every other node, as you add them, that you create that directory structure and add the permissions. Because during the install, that warning on the primary node, the first node, is the only warning and reminder that you will get from SQL Server. It will not pop up on subsequent nodes and go, hey, you're putting TempDB on local storage. You better make sure that you go out and create this folder and give it permissions. It will not say a single thing. There's not a warning, not a reminder. That might be fine if you're building the whole cluster right now. But if you have to evict and add a node 6 months down the road, or just expand it to grow it out and add another node a couple months down the road, you might go in and add a node, it doesn't warn you, and completely forget about it. And then what happens is when you fail over to that node, SQL Server can't start because it doesn't know where to put TempDB because it doesn't exist. And SQL Server, then what happens is the cluster will actually attempt to fail back to the node that it was on. Hopefully it's not because that node went down. Otherwise, if you only have 2 nodes, you're completely up the creek without a paddle. So be very, very aware to make sure that you create that structure and give those permissions. Whatever you do, always keep that in mind, or it could bite you severely. Flexible failover policies. So previous to this, we got what we called looks alive and is alive checks. The looks alive check was just a ping, and all it really did is quite literally just pinged every node. Every node in the cluster would ping each other just to make sure that it was up. But all that does is mean that the NIC card is responding to pings. Quite honestly, that doesn't mean that SQL servers are actually even running. It doesn't mean that your databases are up. It just means it's responding to a ping. That's great. I have actually seen operating systems blue screen before and still respond to a ping. I've seen them completely freeze and still respond to a ping. That clearly doesn't mean that they're up. IsAlive took it a step further and said, not only am I going to ping it, but I'm going to query SQL Server. I'm going to do a select add at server name to make sure that SQL Server is responding, which means the OS is at least up enough and SQL Server is up enough to be responding. Now that doesn't mean that the database in question isn't in suspect mode, that it isn't in a standby mode or restoring mode. It just means that SQL Server is responding. So what they've done now is they've taken it further. And so you'll notice that that second bullet point under the 3 failure detection types says SP Server Diagnostics. Well, SP Server Diagnostics is a new, and you don't have to actually have a failover cluster installed for this. If you're running SQL Server 2012, you can go query this on your own right now. If you do exec SP Server Diagnostics, it takes one parameter. It's a number. The number is how often it will respond in seconds. So if I say exec SP Server Diagnostics 10, then what happens is when you run that query, normally when your query is done, Management Studio will tell you that your query is executed successfully or you've had an error. This will run infinitely. It will never stop until you tell it to stop. And what it's doing is it will query SP Server Diagnostics every 10 seconds. You'll see a new result pop up in Management Studio down there at the bottom every 10 seconds, or however long you decided to give it. And this is literally what the Windows clustering side, Windows cluster is querying SP Server Diagnostics in order to get more detailed information back. And the information it gets back are conditions, and the levels are from 0 to 5. We don't have time to talk about that today. If you're going to be at the PASS Summit in November, I'll be teaching an expanded, longer version of this session. I encourage you to come visit and see me and say hi to me and sit in the session where we'll get a little bit more in depth and we'll have more time and we'll talk about these different levels and what they mean. But for now, just know that 0 is the least restrictive and 5 is the most restrictive. And what that does is just give me more options other than it can ping and SQL Server is responding. Now I have more options available to me that I can fail over at different other more specific error levels. So now that we've talked about FCIs, let's talk about availability groups a little bit. So take failover cluster instances and everything we just talked about with FCIs, kind of toss it out of your mind for a minute, and let's just focus on availability groups, because I really want your mind to be separated that these are two completely different technologies. Now, the advantage to an availability group here is exactly what the word availability group means. It is a group of databases, and we can fail them all over together. But what availability groups really are is it's kind of mirroring. I call it mirroring redefined, right? It's the new reborn version of mirroring where we've kind of taken the best of both worlds, and you'll see how some of the clustering comes into play. But it kind of takes clustering off the Windows side, it takes mirroring, puts them together, and makes them awesome. That's really what an availability group comes down to. So think in your mind that this is essentially mirroring. There are some requirements. The first 2 bullet points here is that it requires Windows Server 2008 or later, and it requires SQL Server 2012. This is an enterprise-only edition feature. I point those 2 out because there's kind of a disjoint there. That we can do it on Windows Server 2008 was when it was supported in the operating system, but unfortunately Microsoft didn't put it out in SQL Server 2008 and 2008 R2, which came out along the same timing lines as Windows Server 2008. You would think that those would match, but unfortunately they don't. So availability groups was not supported until SQL Server 2012, and it is an enterprise-only edition feature. You do have to have a Windows Server failover cluster. Okay. You do not need a SQL Server failover clustering instance, which is what we just talked about. You do not need that anymore or for an availability group. But you do need a Windows Server cluster underneath. So the operating system has to be clustered. So think of this. That is your base for both failover clustering and availability groups, is to have the operating system clustered underneath. That is the basis of both of these technologies. You have to have that in place first. Do not put it on a domain controller. I actually architected all of Verizon's Active Directory prior to getting into SQL Server. For the love of God, from a domain controller, a domain admin perspective, and an AD guy, do not ever put anything on a domain controller other than a domain controller. Thank goodness. Unfortunately, this is not something you can add to a DC, which means that even if you're playing with this in a sandbox environment, this is not going to work for you. Don't put it there. Only user databases, so master model and MSDB, we cannot include those in availability groups, and every single database you do add to an AG must be in the full recovery model. Now, the second you hear full recovery model, you should have a red flag going off in your head going, that's right, I need to be doing what? Yes, transaction log backups. So because they're required to be in full recovery model, that means you're required to do transaction log backups. If you don't, your transaction log fills up. When the transaction log of the physical drive fills up, what does SQL Server do? It's going to put your database in read-only mode, and it is pretty much done with you at that point. So be absolutely certain that when you do this, that you've got backup jobs in place for your log files. A few things that are not required. Like I said, a SQL Server failover cluster instance is not required for an availability group, just the operating system. So separate your mind. Before, we've always thought of the Windows Server cluster and a failover cluster instance. They've always kind of been one and the same because they're always deployed together. And I find that our minds have really melded those two things together. But I need you to take those two things and separate them now. In your mind, all three of these things are completely separate. Failover cluster instance, the Windows cluster, and an availability group. We also don't need shared storage anymore. So that's also a really cool thing because we're literally mirroring and making copies of our databases on every single node that's in the cluster and also part of the availability group. We call those replicas. There are a few prerequisites, okay? So full recovery model, we talked about that. Before you instantiate an availability group, you must have taken a full backup and a log backup of the database prior to initiating. The backups then have to be restored on each secondary server. So if you've got 4, 5, 6, 7, 8 secondaries, then you will have to restore the full backup and the log file on every single one of those nodes before you instantiate an availability group. Now, a few different ways you can do that. You can do it with third-party products. You can also do it using SQL command. You can do it using PowerShell. So you can script all of that out in order to back up and restore those databases on each node. You may find that if you have very large databases, though, you may not want to do all of that at the same time. You would probably rather have the restore be a continual process built and running. That way it's pre-staged and ready to go for when you're ready to implement. So the Windows Server failover cluster, again, it is an underlying support for availability groups. It is required for the operating system and Windows Server to be clustered. Don't require an FCI here. So I note that they're mutually exclusive, but they can be used together. So you can use both of these together if you want. A failover cluster instance is allowed to be added to an availability group. There is a little bit of a gotcha with doing that, but it can be done. Windows Server failover cluster provides a few really handy things, some things that we saw with mirroring, some things that we didn't. But the first one is quorum. And quorum is our decision-making process that decides is my cluster up or is my cluster down? Is node 4 up or down? Is node 1 up or down? So that is the decision-making process that allows us to decide whether things are up or down. It also abstracts our IP and network name. So what that means is if I have 4 different nodes and I have an availability group running across those 4 nodes, only one of them can be active at any given time. So you don't want to connect to node 1 because if it fails over to node 3, you're still pointing to node 1, and then you'll have to reconnect and point to node 4. But how do you know that it failed over to node 4 instead of node 2 or 3? Well, you don't. That's where abstracting this IP and network name comes in. SQL Server will consider it a virtual network name. Inside the cluster, you'll see this built in as a resource in one of your roles. You'll see it as groups if you're running something prior to Windows Server 2012. But it allows me to have a single network name, and that name gets moved around dynamically on whichever node becomes live at any given time. So that's the only one we ever have to connect to. We never have to know which node the availability group is currently running on. And it also monitors the SQL health status. So remember that SP Server Diagnostics, the cluster itself, from the operating system standpoint, is querying SQL Server's SP Server Diagnostics. So let's look at what an architecture of an availability group could look like. So we have 5 servers here. Now, this is 5 different operating systems. Now, they could be physical servers, they could be virtual servers, but just know that they're 5 different operating systems. All 5 of those are clustered together at the operating system level. Okay? There is no SQL failover cluster instance installed here. This cluster exists only at the Windows Server operating system level. Then what we've done is we've installed an instance of SQL Server locally on all 5 nodes. So there are 5 completely separate installations of SQL Server, 1 per server. Our availability group sits across those 5 nodes. And inside the availability group, my first one there is my primary replica. In this availability group, as you'll see, I've got a representation of 3 databases there. And then all the others are secondary replicas, 2, 3, 4, and 5. So I've got 3 databases inside this availability group. It's stretched across all 5 servers, which all have their own instance of SQL Server. So unlike an FCI, where we have a single install of SQL Server that floats around between these, we've actually got a completely separate install, a standalone instance of SQL Server on every node. And then that database, all 3 of those databases, we have a copy of all 3 on every single node. So there's no shared storage here where we have that single representation of our physical database files. We actually have identical copies on every single node. So in this example, we actually have 5 different copies of our database. So what are the advantages of having and using an availability group? The first one is we get multi-database failover, and that's really what an availability group is. In its most basic definition, it is a logical grouping of databases. And the handy part about that is it means that if I have a particular application that requires, I don't know, 5 databases to support this application, if you were using mirroring prior to this, mirroring is on a one-to-one database level. So if database number 2 failed and it flipped over to a secondary where you're a mirror server and a mirror, that meant that you had 1 database sitting on a particular server and you had the other 4 sitting on the primary server. Well, applications don't play nice with that. They don't want to see that. They need everything to be together. So what this does is allows me to logically group all of those databases together and say, look, if any one of those guys fails, doesn't matter which one, if any one of them fails, I want you to fail all of them over together and keep them together as a group. So that's a really cool thing if you're in that situation where you've got multiple databases supporting a particular application. Availability replicas. Each instance of SQL Server that we kind of saw, that we just built out there, can only house a replica. And a replica is a copy of the availability group, which is all of the databases. So each instance that we saw there can only house one replica. So if you've got an availability group that's got 3 databases in it, for some reason you wanted that availability group to exist twice on a server, that you cannot do. Each instance can, however, house a replica for multiple availability groups. So you could have 4, 5, 6 availability groups. The limit is all what your hardware can handle. There's no technical limit on that other than what your hardware can handle. You can have multiple availability groups, and each instance can house a replica for that. What you cannot do, though, is go, oh, in order for me to have multiple copies of a database on a secondary node, is I'll take the database, I'll create 2 availability groups, and I'll add the database to both availability groups, and that'll give me 2 copies. SQL Server knows better than that, and it will not let you do that. So with this multiple replicas, some of you may be wondering exactly how many replicas can I have? And that depends on the version. If you're running SQL Server 2012, you have 5 total replicas. You have your primary, 1 primary, and you can have 4 secondaries. In SQL Server 2014, Microsoft gave us 4 additional secondaries. So that allowed us to have 8 secondaries and a primary, which gave us a total of 9 replicas with SQL Server 2014. So I'm going to jump into a little bit of a demo here, and really all I want to do is just show you what it looks like. So let me bring up my virtual machine here. So what we're looking at first here is the operating system. This is Failover Cluster Manager. And you will notice here that I have, and actually technically have an FCI installed here and an availability group. So looking at the failover cluster instance first, here's what we're going to see. And let me stretch this up a little bit so we can see this. So down below are all of the resources that we'll see for my fit. And this is an FCI we're looking at first. So we can see that I've got some storage here, because remember with an FCI, I have to have shared storage. So I can see I've got a J drive here for my data files. I've got a K drive here for my log files. Scrolling down, I'll see that I've got a network name. Okay, so this is what in Management Studio, when I open up Management Studio, if I wanted to connect to this, this is what it's called, SQL Clus 01. That's what I would type in to connect. This is the IP address associated with that. And then, of course, I'm going to see the SQL Server Service resource, the SQL Server Agent resource here as well. And that is all the typical things that we will see with a failover cluster instance and the resources that we have. That's what we'll typically see. So that's kind of what we see here. The availability group is much more simple when we look at the resources, because all we really see is the network name, which is technically not required. You can connect to the nodes individually, but it is highly encouraged to use one, because if you were to fail over from one node to another, then you'll have to reconnect and know which node it's running on. We can abstract that if we have this sitting here. All we have to do is connect it to app1AG, and it doesn't matter what node it's sitting on. And speaking of nodes, if I click on the nodes over here on the left, I'll see that I have 5 nodes. They're all currently up. I can see my quorum votes, who's assigned in current vote. So I've got 5 nodes here. If I come down and I look at storage, I can see the storage disk that I've got here. I've got a quorum drive. These are the 2 disks that we just saw. The J and K drive is what these are. So we can see all that stuff in our cluster. Now, I didn't need this FCI here. I can uninstall this guy. So even though we need a Windows Server cluster in order to have an FCI, we need a Windows Server to have an AG, we don't necessarily need this FCI. We could get rid of this and just have the AG itself. And you'll notice that this AG, there's no storage here. There's no J or K drive, nothing for data log files. We don't see anything here. And that's because those databases are stored locally. So if I flip over, if I open up Management Studio here, and let me reconnect. So this is app1AG. So this is the availability group. So when I connected, I didn't type in node 1, node 2, node 3, 4, or 5. I typed in app1AG to connect to. That way it doesn't matter what node it's on. If I wanted to, I could open up a query. If I wanted to find out what node it was currently running on, we can just do a select add at version. Oh, I'm sorry. What am I doing? Version is not the one we want. Let's hope I remember this. I think that's what I get for deciding to type in a demo. Let's hope I remembered it. Node 1, that's what we're currently running on, is node 1. So you can always run this query and find out what node you're currently on. Now, as far as the availability group itself is concerned, I can expand. So here's where they hide everything. You can see I have some databases here, right? So I've got and I name these app1, AG, database 1, 2, and 3. So there's an app called app1. This is availability group, contains these 3 databases, database 1, 2, and 3. You can see they're all in a synchronized state. But to dig into that a little bit further, is this always on high availability? We can expand that, and then this is the only availability group we have. I called it app1AG. So you can see that name matches exactly what I connected to. This availability group listener, that network name and IP address that we saw on in the Windows failover cluster piece, that's where it came from. SQL Server created that during the install when we create our availability group. I wish I had time to walk through an install today and show you all that, but unfortunately we don't have enough time for that. And expand the databases so I can see that indeed all 3 databases are included in this availability group, and here are all the replicas. So there's a copy of all 3 databases on all 5 nodes. So hopefully that kind of gives you just a little view of what an availability group and an FCI look like inside the cluster inside of SQL Server. I know that's just a simple quick overview, but again, it's just an intro to kind of get you introduced to things and just kind of understand where everything lives and how it sits and what it looks like, what the architecture design is kind of looking like. So I hope that kind of helps clarify that it's always easier for me if I see stuff. So let me flip back over. We're going to go back into our slide deck here. All right, so replica failover modes. The first one is automatic, and this just means how can we fail over from one node to another. And the first one with automatic means a couple of things. It means that there's not going to be any data loss. And the reason there will be data loss is because synchronous mode is required. So no data loss and synchronous mode are synonymous with each other. If you see no data loss, that means you have to be in synchronous mode. If you're in synchronous mode, it means you're not going to have any data loss on a failover. In order to get automatic failover, I've seen a lot of people think, oh, well, that just means I need to turn synchronous mode on. That way I'm not getting any data loss and it'll fail over automatically. Unfortunately, that is not true. You also have to check off if you're going through the GUI, or if you're using T-SQL, you have to define this parameter, is to actually turn automatic failover on. So just because you're in synchronous mode doesn't mean that it will automatically fail over. You do need to enable that. It is not supported if any primary secondary replica is on a failover cluster instance. So remember, I told you that although I've tried to separate you and say, look, take your mind and break failover clustering and Windows clustering apart and realize that they are 2 separate technologies, one sitting on top of the other. Availability groups is also sitting on top of that. We can mix those. So a failover cluster instance can be added to an availability group. The kicker to that is that you cannot have automatic failover. So that replica that is hosting the FCI, you cannot enable automatic failover for that. Of course, our other choice, if we have manual failover, is going to be, or with automatic, it's obviously manual. If you have an FCI, this is your only choice. This is the only shot that you're going to get. Okay. And if you're doing a manual failover, it can happen in one of 2 ways. And the first one is planned. Planned means I'm doing it on purpose. I'm planning to do this failover. So it can't be asynchronous. Why? Well, because asynchronous means that you could have data loss. If I'm failing this over intentionally on purpose, I don't want data loss to even be a possibility. So that means that we will actually, if it's already in async mode, we will have to switch it to synchronous mode before we can fail it over. Everything also has to be in a synchronized state, so if it was in async, you had to change it to synchronous mode before you can fail it over. You have to wait for it to catch up and be in a synchronized state. And forced is not what you want to see, because that means that something bad happened, but at the same time, that's also the whole reason you created this to begin with. This is the whole reason you have an availability group, is for exactly this reason, is because it is to protect you in case something bad happens. So obviously there's a potential data loss there. Your primary replica's failed, it's flipped over to a secondary, and there will be a possibility of losing some data. So those secondaries are actually active. And what that really means is that they're readable. So the one interesting thing that we had with mirroring is the secondary database, or the mirror, we couldn't do anything with that guy. You couldn't read from it, you couldn't query it, you couldn't do reporting off of it, you couldn't touch it. The only thing you could do was take a snapshot. Well, with availability groups, we can now read from our secondaries. And that's awesome, because not only does it mean that we can have reporting, but it also means real-time reporting. So we can build our reporting services and our reports based and push, instead of having those point to our primary, we can have them point to a secondary, which means all of that load and I/O overhead can be removed off the primary and focused on one of my secondaries. And that's huge, to be able to remove that I/O and get that off my primary, where all of my user connections and all the important actions really occurring at. It also allows reporting to be more real-time. So whereas before we would maybe mirror and do snapshots, we might do log shipping, there's a delay built in there. But with this, it would be real-time. We can also take backups, so all the I/O overhead of backups, and the I/O overhead of doing DBCC consistency checks. We can offset both of those onto a secondary and get that I/O off the primary from affecting your active users. So there are some huge performance enhancements and advantages with an availability group. The kicker to the backups is if you're using differentials. If you're taking backups off of a primary, you can still use differentials, but you cannot do them off of a secondary. So if we're using differentials, keep that in mind. A couple of gotchas with that active secondary. There's a possibility that you could get dirty reads in order to make those secondaries readable. The technology behind the scenes that they're using there is snapshot isolation mode. You can't create separate indexes, so if a secondary server were a reporting box, it'd be really, really handy if I could put different indexes on there, because my reporting workload is not going to be the same as my production workload. But unfortunately, you can't do that. Whatever indexes you create, you have to create them on the primary, and they will get replicated over to the secondary. So you cannot have separate and independent indexes on secondaries that are different from your primary. Whatever indexes you create have to be created on the primary. They're going to exist and get replicated to all the secondaries. Now, statistics are a slightly different story. Now, statistics, there are a separate set of statistics stored on the secondary. So you do get the advantage of the workload. So you could create an index on the primary that's just for your reporting workload, and in theory, the optimizer should pick the right plan, because your workload is different on your reporting box than it is on your active box. And what is going to allow it to do that is that the statistics are separate. Now, you can't always guarantee that that's going to happen, and things change, and that's always the same with indexes and statistics, and which index that it happens to use, how good are your statistics updated. Look at the heuristics and figure out, is this exactly where I'm going to go? Will the optimizer really pick this other index on a secondary because of the queries being different and having a different workload? So having separate statistics will help that. The kicker is they're stored in TempDB. What happens to TempDB when we restart SQL Server? Well, it gets wiped out and recreated. So your statistics are only as good as your most frequent restart of SQL Server on that node. So keep that in mind. It also means that my use of TempDB is going to be much heavier, so I may experience more TempDB contention and may need to troubleshoot and be aware of that and look for that, because that could very easily happen. So when we connect to a read-only secondary, there's a few different settings when we create our availability group that we can provide every node in a secondary spot. And we can say the read intent setting can either be no, meaning that when you connect to this node when it's acting as a secondary, you may not read from it. No means no. You cannot read from it, you can't touch it, nobody can touch this thing or do anything. Yes means great, doors are open, everybody come in. Everybody come in. No restrictions, everybody can read from this no matter what. Now read intent is an interesting animal. It is not a security measure. All read intent means is that if somebody connects to that when it's in a secondary mode, application intent equals read only must exist in the connection string. If it does not exist in the connection string, you will not gain access. But all it takes, if you're thinking, oh, well, I'll keep my users out of this so that they can't query this secondary by telling it that it's going to be a read intent, and then all it takes is one Google search for them to figure out that, oh, all I needed to do is add application intent equals read only to my query string and I'm in. Okay, so there's no security involved there. As soon as they add a connection string, they're in. So there's a level of obfuscation there, but not a security mechanism. We've already talked about the availability group listener. That is what allows me to connect to my availability group and not have to know which node it's being hosted on. So inside SQL Server, if you're going through the GUI, you'll probably see in a lot of documentation, you'll see what they call VNN, or a virtual network name is the word that they use for that. And that is going to be the name that you use to connect with. Again, that it can have more than one IP address. What you saw in my demo here when we kind of discovered what I had configured, I only had one IP, but we could have multiples if they were in different subnets. You can view all that stuff in Cluster Manager. So even though you go through the install and you create all this stuff in SQL Server, I showed you what it looked like in the Failover Cluster Manager, so you can actually see all that stuff in the actual Cluster Manager itself as well. So here's what we've kind of talked about today, just as a recap and a little bit of a summary. We talked about the always-on feature set. The feature set is a failover cluster instance and an availability group. So remember, let's make sure we know which one we're talking about. When we talk about that feature set, it encompasses both completely different technologies of an FCI and an AG. We talked about Windows Server clustering and how important that is, because that is a basis for everything else. We have to have that for an availability group. We have to have it for an FCI. Multi-database failover. Now we can group all of those together logically to support an application. If any one of those fail, they all stick together. Peas in a pod. They're all buddies and friends. If anybody of them fails, they're going to support each other. They're all going to move over together, which means that that app is still going to be able to run and continue running instead of having its databases split between multiple nodes with 2 databases on this node and 2 over here. We won't have that situation. We talked about an availability replica, how every instance of SQL Server that we have running all these different nodes in our AG is an availability replica, and how we can actually read from those secondaries. So we've talked about an awful lot of stuff today, but I hope that this has given you a good basis and a good beginning understanding of the entire always-on feature set of FCIs and AGs today. Make sure you go out and follow me on Twitter if you're out there on Twitter. With that, if anybody's got any questions, I'd be happy to take some questions.
Yes, we have quite a few questions here, so I can read out some of them to you. There's a question about if there is a possibility to have secondary replicas that are read-write. So not just read-only.
Yeah, so secondary replicas can only be read-only. They cannot be read-write. So the only read-write that you get is the primary.
Okay. So another question is, how would you handle getting stored procedures stored in SQL Server and agent jobs in place on the secondary replicas?
So that's an excellent question. And the stored procedures you don't have to worry about. So those are part of your database, so those are all going to come across. But what doesn't come across is anything that's at the server level. So if I have things like logins, endpoints, link servers, those types of things at the server level, those aren't included in an availability group. And the reason for that, now with an FCI they're included, right, because that is an actual identical copy of everything that we're moving over. So with an FCI, I'm good to go. But with an availability group, I'm not. And so you will have to find a way to get those things moved over. Logins, roles, all that kind of good stuff. If you hit my blog, and I wrote this quite some time ago, it was a blog post, and it was in regards to mirroring, but the same thing applies here, is I walk through how I started to write a store procedure that I could put in a SQL agent job in order to move all of that stuff over automatically for me. I got about 95% done reading that when I realized that Robert Davis actually wrote one, and his version was 10 times better than mine. So I use his. You can hit SQL, if you read through my blog post, it'll give a link to his where you can actually find his store proc, and that's what I use in production today. And it'll move all of those logins and everything over. But the store procs you don't have to worry about. Those are part of the database, and they're already going to be there.
Yes. There's a question about can you have replicas in a different domains?
No, you cannot have replicas in different domains. And so the main reason for that, and that's the one kicker, so with mirroring, you could actually put things in different domains. So your primary and any mirror could actually be in completely separate domains because we could use certificates in order to create that security link. The reason you can't do that with an availability group is because of the Windows clustering sitting underneath, and Windows clustering has to be in the same domain. And it's even trickier than that. 9 times out of 10, coming from a domain admin perspective, I can give you guys a really good different perspective that a lot of people can't give you from the domain admin piece, is a lot of times you don't have to be in the same domain. You can actually be in a different domain as long as it's in the same forest or it's trusted. And you've got a two-way transit of trust. Unfortunately, with a cluster, you absolutely literally have to be in the exact same domain. Having one node in one domain and another in a trusted domain will not work. So the entire cluster and everything has to be in a single domain.
Okay. There's a question about if availability groups work by replaying the transaction logs.
Yeah, so without getting too in-depth with the internals on that, in your mind you can think yes, but technically speaking, no. And mirroring's like that too, and we tend to talk about it as, hey, this transaction happens over on my primary, and that transaction gets replayed or redone, maybe as in a redo, because if you go look at it, if you look at the secondaries, you'll see that they're in a restoring state. So it looks like I'm literally doing a backup and a constant restore. And it is doing that, but it's not doing it in the way you think it is. It's actually doing it at the block level or the extent level. And it's actually copying the data over in chunks of data as opposed to the transaction level. But it does still keep track of the LSNs in order to keep up with where it's at in that restore process.
I think we maybe have time for one more question. There is what do you connect to when you want to read from secondary because of the alias?
So I didn't have time to do that today and get into that. If you come see my session at the summit, I'll have a little bit more time to get into that. But what he's asking here is when I go and I want to connect to a read-only secondary, I don't want to go to the primary, I want to go to the secondary. How do I handle that? And so unfortunately there's nothing in the GUI it's called read-only routing. So if you're going to research and look it up, read-only routing is what you want to go Google for, or Bing, whatever you want to use there. And with read-only routing, there's nothing in the GUI to set that up with. It's all T-SQL. However, I will tell you that Denny Cherry has a really handy app that he has written that I use myself that will automatically go through, and you just tell it, hey, look, these are all my nodes, and it'll automatically build out the T-SQL for you, and it'll go out and run it, and it'll set up your read-only routing for you.
Okay, that's all we have time for. Ryan, you can maybe, we have a lot of questions we haven't answered, so maybe we can send them to you, and you can answer them on your blog or some other venue.
Yeah, so if you guys follow me on Twitter, what I'll do is I'll grab all those questions and I'll write a blog post and answer all those questions, and then I'll tweet it out once I get that posted. That way I can get everybody's questions answered.
Okay, great. Thank you all for attending the session. And this is it for 24 hours of PASS.
Great. Thank you, everyone.